Hey guys, welcome back to my channel. This is Varun Tahin. So in our previous session, we started with the DQL, which is data query language, and strategized the queries as per different requirements to get details from the database by querying different tables. Now we will be continuing to answer some of the other questions that were left and see how we use aggregate functions along with the clauses and subqueries. Also at the end, we will look into various joins and how we can leverage that here to answer some of the complicated requirements which requires us to fetch the data from multiple tables. So now let's continue to answer the questions. Okay, this is the first one for today. It says display the average, minimum and maximum hours spent in each project. So clearly this is the case for works on table. So we'll just expand this table, see the columns and apply the aggregated functions. So we'll say select p number comma average hours, then minimum hours and then maximum hours. From which table? From works on group by p number. So why we are doing group by here? Because we need hours spent in each project. Okay, so this will give us the answer. So here you will see that there are individual project numbers and this has segregated the average hours, minimum hours and maximum hours spent in each project. Now the next question says display the year-wise count of employees based on their year of birth. So as you can observe that employee table has the column of birth date. So we'll extract the year from this. So I'll say select year, function that I'm using birthday and then count star, because you have to count the number of employees. Okay, so I'm counting the records from employee table, group by year, b date and then order by year, b date. Okay, so we are also doing the ordering in the same query. Now let's run this. Okay, now you will see that there are numerous employees and you are getting for each year one record. Okay, so one employee is present for whom the birth year is 1937 and likewise. So there are only one employee per year. Now the next question is display the department number of those departments that has at least 3 employees. So for this we will write a simple query, select d number comma count star. Okay, so guys, here remember that we have to again for each department we have to group it by d number. And remember guys, in the first session, introductory session, we have also spoken about having clause, so we'll use that here. So having count star is greater than 3. So right now it is putting a clause here that the number of employees in each department should be greater than 3. Now let's run this. Okay, so only department number 5 has a count of 4 which is greater than 3. The rest of the departments have less than 3 employees in it. Okay, we can also tally this by simply going and doing a select star from employee. So let's tally this. So I'll just do select star from employee and we'll manually count it and see whether our output is correct. Okay, so department number 5, you can see 1, 2, 3 and 4 employees are there. The rest, department number 1 has 1 employee. Department number 4 has 3 employees in it. So that is the reason department number 5 is returned. Now the next question is, among the people who draw at least 30,000 salary, what is the department wise average? So this we will segregate the query. Okay, so I'll say select d number, okay, from employee where salary is greater than or equals to 30,000. Okay, and we have to group it by department number. And what finally we have to do is we have to calculate the average salary. So average salary, sorry, this should be department number. Let's run this. Okay, so it has returned 3 departments with the average salary of each one of them, which is greater than 30,000. Now the next question says that instead of department number, we have to display the department name. Now here all the things will remain the same, but since we would like to return the department name and it is not present inside the employee table, you can observe here, okay, only department number is present. We have to fetch those details from the department table. Okay, so department name according to the department number present in the employee for that particular employee. employee. So what we will do is we have to do the joins here. Now before writing any query, I would like to introduce you all to the concepts of joins. So the join refers to the merge and display of the columns in two or more tables based on some column and its values. So in SQL there are many joins, but majorly we use these four joins extensively, which are inner join and outer join. And in outer join there are three types: left outer, right outer and full join. Now we have seen the inner concepts in pandas too, and if you can recall, it is based on the similar values of a column present in both the data frames. Likewise here too, the inner join will basically only join and display the records from the tables where a particular column on which we are joining contains the same values for those tables, and we will see the examples of it in coming questions. But the outer join is used when we want to display the rows in one table even if they do not have a corresponding entry in the other table. Now the use of outer join is, let's say that we do inner join of the employees and the dependent table. So you will get only those employees who will have at least one dependent. So here, to avoid the loss of the information, you can use the outer join. Now in an outer join output, all the records from the left table will be there in the output whether the link is there or not to the right table. Okay, so this Venn diagram you can see on the screen that represents the intersection of A and B as well as A. So that means all the records of the A table will definitely be there, and respectively for the right outer join, the output will be having all the records from the right table whether the link is there or not to the left table. And in full outer join output, all the records from both the tables will be there in the output whether the link is there or not to any of the tables. Now guys, remember in outer joins you will notice some null values, and those are expected to, as some or the other columns will not match. Now that we have understood the concepts of join, let's try and frame the query for this question, which says instead of dnumber display the name. Okay, so for this I'll just select this, okay, and just press this here, and we'll now rectify the query. So from employee this will be remaining the same, also the where clause will remain the same, but here we will be doing the inner join. Okay, so I'll just write inner join department on. So the column name here is dnumber equals to department number. Okay, so department number is what is present in the department, so we'll just equal this to dnumber, and then where clause, and then the group by dname, and we'll also order it by dname. So order by dname, and instead of the dnumber we'll use dname here. Now let's run this query. Okay, so you will notice that instead of department number, now the name of the department is coming with the average salary. Now the next question here is display the F name of employees working in the research department. So again guys, this is a complex query, and there is a concept of subqueries in SQL. Select, inside a select you can write, okay, so we will be writing the same, so I'll be showing you. Okay, so I'll do select F name from employee where dnumber equals to, and here we will write another select query. Okay, so we have to select the department number where the d name is research. Okay, so we'll just do a select on the department table. I'll do select dnumber from department where d name equals to research. Okay, now when this happens we have to order it by F name. Okay, so this is just to make it more readable. Okay, I'll just execute this. So you will see that all the employees who have the department name as research are returned and its F name are displayed. Now the next question is display the F name and salary of the employees whose salary is more than the average salary of all the employees. So here also we will use the subqueries. So we will say select F name comma salary from employee where salary is greater than and equal to, and then we will select the average salary from the same table. Okay, so we'll say average and then salary from employee. So we can even do this guys. Okay, let's run this. Okay, so this has returned the output. Now we have this question in which it is asking which projects have the least number of employees. So this is again a subquery example. So we'll do select p number comma count star, and we'll just name it as alias numemps from works on table, because we will be fetching the details from works on where ESSN, project number and hours are there. Okay, and we'll group it by P number. Okay, that's project number, and we'll use having clause. So having numems, and here we will do a subquery. So select minimum of NEMPS. Okay, this is another alias that we will use from select P number comma count star NEMPS from works on group by P number, and we'll name this as TEMP project. Okay, you can do this or not do this, it's up to us. Okay, and we'll just close this. Sorry. Okay, when we run it, you will see that the project number along with the minimum number of employees will come here. Okay, so project number 1 and 3 have minimum number of employees, which are 2. So how did we come up with this query is, we will first select the count of the employees, okay, from the works on table, group it by the project number, and then again select the minimum number of employees from it. Okay, so this will be stored in numems, which is a temporary kind of a temporary variable in SQL, and then it will be returned at the last after grouping on the project number. So now let's see some of the examples of joins. So first one is inner join between employee and dependent. So for this I will just create alias for both of the tables, and let's select some of the columns. Okay, so for employee I'll select E, so I'll be choosing e.ssn as a column name, and then e.fname, and then for the dependent table I will be using D as an alias, so d.dependent name, and then from employee E inner join dependent D on e.ssn. okay, because we have SSN in the employee table and in department we have ESSN. okay, so we'll do equals to d.essn. okay, let's see what it returns. Okay, so it has returned these many columns with the joins. So basically it has tallied the SSN with ESSN and it has returned the rows. Okay, so F name is coming from the employee table and dependent name is coming from the dependents table. And likewise for the left join, we just have to change the clause. Okay, so instead of inner join, we'll just say left and run this. Okay, now you will see it will start having the nulls also, because as we have discussed, the left join, irrespective of the match or not, it will still have the records of the left table, which is the employee table. But in the dependent table, those entries for those fname or those SSN are not present, therefore it is having null. Now we will see the right join. Okay, so I'll just copy this. Okay, change this to right, and this time let's have this on the right and dependent on the left. Okay, so I'm just changing the positions for them. Okay, let me run this. So you can see the results are still returned. Now there are a lot of similar questions which we already covered and are present in the select queries company DB. So I'll not be covering all of them right now, as those are already covered and you can refer those and you can write the queries for them. For some of them the answers are already provided. So I'll be taking two last complex queries and tell you how to write the queries for that. So the first one is display the SSN, their department, the project they work on, and the name of the department which runs that project. Okay, so it will be covering all of the tables that you created, and it will need 5 table joins with various columns such as SSN, employee department name, P name, and project department. So we'll expand all of them and we'll see how to write this query. Okay, so I'm just expanding all of them and expand the columns as well. Okay, now as the information is spread across the tables, what we will do is, first we will join the employee with department using the department number, because department and employee has D number in it. You can see here D number and D number. Then we will join this table with works on table using the SSN. So this indirectly will have the SSN, this table, after joining, and then we will join it with the works on table basically. So works on table, you can check that it will still have ESSN from which we will do the join, and then with that we will join the project using the project number. So P number is here and P number is here. We'll do a join, and then at last we will join with the department using the department number. So we'll get all the required columns. Okay guys, now let's write the SQL query for this. So I'll just write the from clause first, and then according to the aliases we'll create, then I will select the columns and write the select. Okay, so from employee e inner join department ed on e dot d number equals to ed dot d number. Okay, then inner join again works on w dot essn equals to e dot ssn, and then again inner join project p on w dot p number equals to p dot p number, then inner join, and the last one is department. So pd on p dot dnum equals to pd dot d number. Now we'll do a select statement. So select e dot fname comma ed dot dname, and I'll name it as employee department, and then we will select the p dot p name, that is project name, and the department name, so pd dot dname. Now let's run this. Okay, so it has returned all the columns which we asked for. So this department name, it has renamed as employee department, and this is another department which is research, which is coming from the project department. Okay, so the last question now is which employees work on projects belonging to departments other than the departments they belong to. Okay, here also we will write the from clause. Okay, so employee E works on W, then project P, and then department ED, and then the department as PD. Okay, so one is the employee department, the other is the project department. Okay, now we'll use where. So where E dot SSN equals to W dot ESSN, and W dot P number equals to P dot P number, and p dot dnum equals to pd dot d number, and the last clause is e dot d number should be not equals to p dot d number. Okay, so the employee department should not be equals to the project department. So that is how we will know the employee who are working other than the projects they are allotted to. Now select e dot ssn comma p dot name comma ed dot dname, and we'll rename this as employee department name. Okay, and then pd dot dname, and this should be renamed as project department name. Let's run this. Okay, there's something wrong. This should be p name. Okay, it's not p dot name, it's p name. Okay, so you have got the respective columns which are SSN, P name, employee department name, and project department name. So you can see the SSNs which are present here have different departments, okay, both in the employee department name and project department name, and you can conclude that they are working for the departments which are not allotted to them. Now guys, this brings us to the end of SQL series. I know that I haven't touched all the aspects of this database. So there are many concepts of locking, procedures, triggers, etc. And it is a never-ending process to learn it completely. But that is not the scope of this series. It is to familiarize ourselves to the SQL world so that we can start with the data analysis, which is the main objective here. But I have some resources with me which you can refer and learn from, and I will post it in the description for you guys. Now I have also an exercise for you. So MySQL comes with an inbuilt database called World for sample exploration and to check how various queries work. I have prepared some questions for you and uploaded in my GitHub repository by the name of worlddbquestions.sql. Please try and answer those as it will strengthen your knowledge and concepts you already learned in these sessions. The answer key is also provided, but I would recommend to only see it if you are stuck somewhere or if you want to tally your answers with them. So thank you guys for watching me. I will be coming with more awesome content on data science on this very channel where you get everything. Until then, please don't forget to subscribe my channel and hit the bell icon for future updates. I will see you soon in the next session. Thanks and take care.